Hello everyone. So once again we are here. I'll be showing one more problem on superposition theorem. Okay. So the question is there on the screen. So this is the third problem in my playlist on superposition theorem. So if you see the other problems, it will also be beneficial for you. So let's try to solve this problem now. So you can also see the problem here and try it yourself, and then later you can compare your answer with my answer. So find the current in 40 ohm resistance. So this is the 40 ohm resistance and we need to find the current using superposition theorem. Okay, so let's start working on this. So again, what is the way in which we apply superposition theorem? First, we consider one source and the other source, voltage source, will be short circuited. If it is a current source, it will be open circuited. And then we'll consider this source and the first one will be short circuited, and like that. If there are more sources, then we have to repeat this for multiple times, and finally we have to find. This one is fairly easy problem, so let's do it. So consider 60 volts. So when I consider only the 60 volt source, the circuit becomes simplified like this. So we have a 60 volt source here, and then I have 20 ohm resistance. Then from here another branch is 5 ohms. Then I have 40 ohm resistance here. Then another branch is 5 ohms, and then this whole thing is short circuited. So now right away, if you see from this point there are two branches. Okay, so and these two are in parallel. So if you can see, this point is same as this point. So 40 and 5 are in parallel, and that parallel branch is in series with 5, and that entire is in parallel with 20. Okay, so that is the way. So the R effective is 40 parallel with 5, and that combination is series with 5, and this whole combination is in parallel with 20. So this will give me the effective resistance. Okay. So then I need to find what is this current, how much current goes in this branch, and then again I need to find what is this current. So for these two I will do the current division principle. Okay, so let's call this as IA, and let's call this as I1. Okay, so the I1 is a current of 60 current in 40 ohms resistance because of 60 volts. Okay, so let's do this first. So what is 40 parallel 5? Okay, so that is 40 into 5 divided by 45. So I'm getting 4.4444. Okay, so that is this one. To that I will add 5. Okay, so plus 5 will be 9.44, and this 9.44 is in parallel with 20. So this one I'll multiply with 20 and then divide by 29.444444, so on. Okay. So now I am getting the total resistance 6.415. So the effective resistance is 6.415 ohms. Now what is the current? So the total current will be voltage by resistance. So 60 volts divided by 6.415. 60 divided by 6.415. So that is 9.353 amperes. Okay, so this is the total current. So this 9.353 is flowing here. Now at this point the current division is happening. So how much current goes in this branch is what we are interested. Okay, so how do I find that? So using the current division principle, IA is 9.353 multiplied by the opposite branch, parallel branch resistance is 20, divided by 20 plus the resistance of this branch. So 40 parallel with 5, I got 4.444 if you remember, plus 5 is 9.444. So 9.4444 and so on. Okay, so this is the thing. So now I'll do that. So 9.353 into 20. Okay, so divided by, so here 29.444. Okay, so 29.444444. Okay, so this is 6.353 is the current. Okay, so I can round off. So 6.353 amperes is the current that is here, IA. So 6.353. Now that current is again dividing here into two branches, 5 ohms and 40 ohms. Okay, so from that I can find I1. Okay, so what is I1? 6.353 multiplied by the opposite resistance is 5 and divided by total resistance is 40 plus 5. So again I apply this current division principle. Okay, so 6.353 multiplied by 5 divided by 45. Okay, so I'm getting 0.70588. Yes, so or 0.7059 amperes. Okay, so this is my total current because of this. So now let us continue, take the other source and then we calculate the current in 40 ohms because of the other source. Okay, so let me once again redraw the circuit. Now the 60 ohms will become short circuit. So the circuit becomes like this. Okay, consider 15 volts source. Okay, so here it will be like short circuit. Then we have 20 here, and then we have 5, and then 40 here, and then again 5 here, and then this side we have 50. So this same circuit I have redrawn by short circuiting the 60 volts. So again if you see 40 and 5 are in parallel, that parallel combination is series with 5 and that entire combination is in parallel with 20. So this was same in the case of 60 volts. So the effective resistance will be same. Okay, so R effective will be same, that is 40 parallel in 5 plus 5 and parallel with 20, 6.415. Okay, so 6.415. Now I'm sorry, this is 15 volts. So here the current will be different. So here one more thing you can notice here is that the voltage is 60 volts is replaced with 15 volts. So it is voltage is decreasing by a factor of 4 because 15 into 4 is 60. So similarly the current will also decrease by a factor of 4 because everything is same. See here for calculating I will be 4 times more compared to 15 volts, and here the same, and here the same. Everything is just a product. So final answer also will be 4 times less. Okay, so directly I will write I2 will be I1 divided by 4 because the voltage is decreasing by 4 times. So 60 by 4 is, so let me show you that. So 60 by 4, in fact I myself want to confirm. So therefore the I2 will be I1 by 4. Okay, so this is we are taking the advantage of linearity of the circuit. Okay, 0.7059. Okay, so 0.7059 divided by 4, so I am getting 0.176475 or 1768 amperes. Okay. If you are feeling doubt, let's verify it. Okay, so how do we verify? First I want this current. Okay, so what will be this current? That current will be 15 divided by 6.415. Okay, so I equal to, so that is nothing but 15 divided by 6.415. So that is 2.33826. Okay, so I got this current 2.33826. Then I want this current. Okay, so how much will this current be? So this current multiplied by opposite resistance, that is 20, divided by this branch resistance, that is 29.44444. Okay, so that is 1.58826 amperes. Okay, so I got this current. Now again current division is happening. So multiplied by opposite resistance is 4 divided by 45. Okay, so I'm getting 1.1417. I think I made some mistake somewhere. Let me cross check once again. Yeah, so I just made a calculation mistake. So 1 point, see this is correct, 1.58826, so that is multiplied by 5 and divided by 45. Okay, so I'm getting 0.1764 so or 1768, so this is more or less matching with that. Okay, so in fact this could be more accurate. So finally in both methods I calculated, so I just took the help of linearity and understood the symmetry of the circuit and finally got the answer, or if you solve it also you will get the same answer. So now finally, what is the final answer for final current in the 40 ohm resistance? So final answer will be I1 plus I2 because superposition theorem, and both of them will be in the downward direction. So the direction also not a problem. So we are getting 0.7059 plus 0.1768. Okay, so let's add that 0.7059 plus 0.1768. Okay, so I'm getting 0.8827 amperes as the final current in the 40 ohm resistance, I40 ohm. Okay, so this is the answer for this problem. I hope my answer is matching with your answer. Congratulations if your answer is matching with my answer. So please press the like button if you like this video, and subscribe to this channel, and my next video will be also displayed as a card in this particular video. So go to the next video where I will be solving the fourth problem in this particular series. Thank you.